Okay, so if you missed class on Friday, you missed some notes. Took notes on Bohr's models of atoms. This is a continuation of our atomic structure notes from yesterday. So go ahead and you don't need a new entry in your table of contents, but you will need this as sort of a new section title, or probably would be wise to start on a new page altogether. Okay, so first thing, Bohr's models of atoms. I'm just going to slide this down. So Bohr's model is not a vocab term right now, but probably next time I update your vocab list, Bohr's model will be on there. And this is going to be a really good definition for Bohr's model. So it's a way to model atoms to show number and arrangement of protons, neutrons, and electrons. And that needs to go in your notes as well. Everything here is going in your notebook. All right. So we need to talk about the steps. And by the way, feel free to pause this video at any point. I'm going to sort of go through this quickly because you can pause me, unlike in class. So here are your steps for a Bohr's model, for making a Bohr's model. First, we want to find the element on the periodic table, right? Second step is a little bit drawn out. There's multiple sub-steps. So it's going to be find the pen numbers. What I mean by that is protons, electrons, neutrons. I found last year that I was saying find your numbers of protons, neutrons, and electrons way too often, and it was going to be easier if I just found a little acronym like that, so that's what I did. All right, so find our pen numbers. The way we do that, first off, we need to find our number of protons, and that's going to be our atomic number. If you remember the notes that we took yesterday, our atomic number is the one up top here. Okay, so that is equal to our number of protons. Our number of electrons, because electrons have a negative charge and protons have a positive charge, and we are dealing with neutral atoms, which don't have an overall negative or positive charge, our numbers of negative electrons and positive protons are always going to balance each other out. Now, we will at some point in the semester be dealing with atoms that have a charge on them, but I will make it very clear when the atom has a charge. If I don't say anything about it, you can assume that the atom isn't charged. So electrons will equal protons. Your number of electrons will equal your number of protons as long as the atom isn't charged. Okay? And like I said, I'll make it very clear when the atom is charged. Usually it will not be charged. Neutrons is a little bit confusing written out. Once you do it a couple times, you'll get it no problem. Number of neutrons is equal to the mass number minus the atomic number. Mass number minus atomic number. And if you remember from our notes yesterday, that the mass number is equal to the atomic mass rounded. So looking back at this again, our atomic mass of carbon is 12.011. If we want to find our mass number, we just have to round the atomic mass to the nearest whole number. So our mass number here is 12. Okay, so our number of neutrons is 12, mass number minus atomic number. 12 minus 6 is 6. Okay, so that's step number 2. If you can find those pen numbers, you're off to a great start. Step number 3 is where we start actually drawing our Bohr model. So we're going to start out by drawing a nucleus with, this is my abbreviation for with, a W with a little slash. Draw a nucleus with the numbers of protons and neutrons. And you'll see how I do that in a minute. For right now, just write this down. And remember, pause this as needed to get these written down. Our last step is to fill in the energy levels with electrons. So again, if you remember from our notes yesterday, we talked about these different energy levels that we have and how many electrons they hold. This is where it comes into play. You don't need to write this down. This should be in your notes from yesterday. Okay, so we're going to start off with modeling carbon, and I'm going to grab a new sheet of paper. Hope you didn't see that. Cheaters. I'm going to grab a new piece of paper, and we're going to do a Bohr's model for carbon. Remember, all of this should be going into your notes. Okay, so we want carbon. Here's carbon's square on the periodic table. We want to find our pen numbers. Proton, electron, neutron. Okay. Our number of protons is our atomic number, remember? So our atomic number is 6. We have 6 protons. For right now, our electrons will always equal our protons. So we have 6 electrons. If these two numbers aren't the same, you're doing something wrong. Make sure those two numbers are the same. For our neutrons, we need to round this number. It rounds to 12. 12 minus 6 is 6. Yes, I know, this is 666, whatever. Don't freak out. Something to note here is that often you will have all 3 of these numbers being the same, but it won't happen all of the time. It won't be every time. So you always need to do this math. Don't just look at this number and assume that that's how many neutrons you'll have as well. You need to do a little math to figure that out, right? So that was step number 2, find our pen numbers. Step number 3 was to draw the nucleus, and I'm going to slide this out of the way because we don't need it anymore. We're going to draw our nucleus, and we want it not real big, but big enough to include 2 things, and that is P equals 6, because we have 6 protons, and N equals 6. Now remember, this is our nucleus, and we have protons and neutrons in the nucleus, okay? That's why we have this drawn like that. Something that you should get into the habit of doing too is, after you do this, cross these out, because you've already handled your protons and you've already handled your neutrons. Now it's very clear that all you need to do is handle your electrons. And that's step number 4. That's filling in the energy levels. So this is our nucleus. I'm going to draw my first energy level around that. Okay. And we want 6 electrons altogether, but if we remember from yesterday, this is our first energy level, and it only holds 2 electrons. 1, 2. I want to put them next to each other. Now, you may have had a teacher before who had you put them on opposite sides of the energy level, maybe left and right, or top and bottom. But for us, we want them paired. That'll help us with something that we'll be learning later on in the year. So this is how our first energy level should look. We have 2 electrons, but we need 6 altogether. So we need to add another energy level. Okay. Now, whenever people are adding to the next energy level, they often forget to count these 2. So people will start adding and they'll say 1, 2, 3, 4. Don't do that. You already have 2. Let's start at 3. 3, 4, 5, 6. And you notice that I started at the top and went clockwise, putting 1 electron at each corner. That's exactly how you should do it. 1 up top, 1 on the right, 1 on the bottom, 1 on the left. And that's our final Bohr's model for carbon. Now, notice that our second level will hold up to 8 electrons, so there could be more that fit into here. Carbon only has 6, so we're just going to stop there. But let's go ahead and look at one where we put a few more in there. So we're going to look at oxygen this time. Here's our little square. Got to find our pen numbers. Atomic number is 8, so that's how many protons we have. Protons and electrons will always be equal for us. Neutrons, we have to round this number. 15.99 rounds up to 16. 16 minus 8 is 8. So again, you can see that we've got 3 of the same numbers. Again, doesn't always happen. Don't assume that it will. Don't need that anymore. I'll get it out of the way. Draw our nucleus. The nucleus contains protons, 8 of them, and neutrons, 8 of them also. Took care of our protons, took care of our neutrons. Next up, we want to figure out our electrons. So we need our first energy level, and that holds 2. Still needs more. We got to have 8 altogether. Okay, and we want to start at the top and add around in a clockwise manner. So that's 2, 3, 4, 5, 6. Now we start doubling up. So that was 6, 7, Okay, now for other atoms, I might go 8, 9, 10. Once I get electrons in pairs all the way around, that'll be 8 electrons. If I have 4 pairs, 4 groups of 2, that's 8. So that would be a full shell. This one isn't full yet, but it's happy with 6. Right? So there we go. There's your Bohr model for oxygen. Let's look at hydrogen real quick, because hydrogen is sort of funny. Tile on the table, periodic table. Protons, its atomic number is 1, so it just has 1 proton. Electrons and protons will always be equal. Neutrons, 1.008 rounds to 1, and 1 minus 1 is 0. So hydrogen actually doesn't have any neutrons. Hydrogen is the only element that doesn't have any neutrons, but it is possible. When you're drawing this one, you still want to make sure you include it. Tell me that you have 1 proton and no neutrons. If you left the neutrons out, I might think that you forgot. So make sure you include that. Took care of my protons and neutrons. Now I just have to do my 1 electron. So here's my 1 energy level and my 1 electron. There you go. That's hydrogen. Okay. Here's where I want you to start trying some on your own. So I'm going to give you fluorine. I want you to see if you can handle this one on your own. So pause the video, see if you can get it. All right, assuming you are back now. We have 9 protons here because fluorine's atomic number is 9. We have 9 electrons as well because these two will always match for us here. 18.98 rounded is, we have to round up to 19, and then 19 minus 9 is 10. So we have 10 neutrons. Slide that out of our way. Draw our nucleus. Protons and neutrons are in the nucleus. We have 9 protons and 10 neutrons. Here's where in class today a lot of people got screwed up. Make sure you cross these out, because a lot of people are trying to draw in 10 neutrons instead of 9. Or I'm sorry, they're trying to draw in 10 electrons instead of 9, because they see this 10 at the end and they're thinking, oh, I've got to draw 10 electrons. No, you have 9 electrons. Okay. First energy level holds 2. That's all filled, so we need to add another one. That's 3, 4, 5, 6, 7, 8, 9. Okay, so we're almost filled up. We have 1, 2, 3, 4, 5, 6, 7 in this energy level. We can have up to 8. We're good at 7. All right, so there's fluorine. We are going to do one more. I'll do it up here. This last one I want to give you is aluminum. So again, pause the video, try this one on your own. All right, welcome back. Assuming you left in the first place. Protons, aluminum has 13 of them. Also has 13 electrons. Neutrons, 26.9 rounds to 27. 27 minus 13 is 14. Slide that out of the way. Our nucleus, protons is 13. Neutrons is 14. First electron energy level. Oh, forgot to do that. That's going to be important. So now we've just got to deal with our 13 electrons. 1, 2. That's all filled. 3, 4, 5, 6, 7, 8, 9, 10. Now this is where people are doing all kinds of funny things. They're trying to add a third one here. Nope, this one is full. It has 1, 2, 3, 4, 5, 6, 7, 8. And if you remember, second energy level can hold up to 8. 8 is the top number, so we need to add another energy level in order to accommodate the rest of our electrons. We need 3 more yet. We've got 10 so far. We need 3 more. So ran out of room here a little bit, but we'll get it done. So this is 10 electrons. Helpful tip is that the first 2 energy levels, if you do it right anyway, add up to 10. So it's a really easy way to it's a place marker. So we have 10, 11, 12, 13. Okay, this one should be sort of more above. Just I ran out of room there. Okay, so seeing as I have 10 there and 3 on the outside, 10 plus 3 is 13, I'm all set. All right, so this is where our notes have ended today. Hopefully this is making a little bit of sense. If it doesn't, that's okay. We're going to be getting plenty more practice. All right, but if you have any questions on any of this, let me know. If it's the weekend or whatever, email me. If it's the weekend, I might not email back right away, but talk to me if you have any questions, and good luck. Make sure this is in your notebook.